Question 10 from Paper 1 of the 2022 Higher Physics exam from the SQA. A proton enters a region of magnetic field as shown. The region of magnetic field is from left to right and the proton is moving down the page. And we're asked to find the direction of the force exerted by the magnetic field on the proton as it enters the field. Well, the first thing we have to recall is that we're dealing with a positive charge. So we have to remember their statement that Elvis Presley said when he left the stage. His aides used to shout out, "Elvis has left the building," and people would reply, "Are you positive he's left the building?" So that's a little way of remembering that if it's a positive charge, you have to use the left hand rule. And there's the left hand rule there. First finger is the direction of the field. The second finger is the direction of the current. That's where the movement of the charged particle is going. And your thumb indicates the motion of the force which will be applied to that. Now in this case, the first finger, the field, is going to be pointing from left to right. And if you hold your left hand up, point your first finger left to right, and the motion of the proton is pointing down the way, so you would turn your second finger to pointing straight down, and lo and behold, your thumb would be pointing out of the page or out of the screen. As a little summary of it here. You're going to have the field moving from left to right. The field is left to right. The direction of the proton is downwards. And because of the left-hand rule, you can see we're going to have the force with the symbol coming out of the screen, a circle and a dot. So the answer to question number 10 would be this one here. It will be out of the page. Question 11 from Paper 1 of the 2022 Higher Physics exam from the SQA. The masses of three particles are shown. We have the particle and we have the mass on the right hand side of the table, the electron, the proton and the Higgs boson. And in this question we're asked how many orders of magnitude greater is the mass of a Higgs boson compared to the mass of a proton. And it's much easier and more beneficial to compare masses of these particles by looking at their powers of 10, the orders of magnitude. So we start with the Higgs boson. So the Higgs boson is going to be in ratio with the, in this case, the proton. Just look at the ratio. The Higgs boson has got a mass of 2.22 times 10 to the minus 25. I'll just ignore the kilograms because they cancel out. And we're dividing by the mass of the proton, which is 1.673 times 10 to the minus 27. Now we look at these parts of the numbers here, we can see 2.22 and 1.673 is approximately 1, so we don't have to worry about that kind of division here. We just have to worry about the division between 10 to the minus 25 and 10 to the power minus 27. So we just compare the powers. 10 to the minus 25, if we're dividing by 10 to the minus 27, we just simply subtract the power which we're dividing by. So it's going to become 10 to the power minus 25, take away minus 27. And of course we take away a minus and we add. So we're going to get minus 25 plus 27, so if we're going to have 10 to the power 2. And we're saying that the Higgs boson is actually 10 to the power 2 times bigger than the proton. In other words, it's 2 orders of magnitude bigger, and that gives you a better way of comparing the masses. So the answer for this question 11 is going to be 2 orders of magnitude because we're looking at the power of the 10. So the answer will be B, 2. Question 12 from Paper 1 of the 2022 Higher Physics exam from the SQA. A proton consists of 2 up quarks and a down quark. And a student makes the following statements about protons. Protons are baryons. Second statement, protons are hadrons. And third statement, protons are fermions. And we're asked to find which of these combinations is or are correct. Well, a quick look at our chart of the Standard Model. And you can see that fermions are really a big family of particles made up of quarks and leptons. And of course, the quarks joining together can make baryons. That's if 3 of them join together, 3 quarks come together, they make a baryon. And if you have a quark and an antiquark together, they make up a meson. Now a proton is a baryon then, so that's our first tick in our box. We know that protons belong to the baryons because they're made up of 3 quarks, 2 up quarks and a down quark. Protons are also hadrons, because hadrons are particles which experience the strong nuclear force. So we can say that protons are hadrons as well. And also protons must be fermions, because fermions are here, and the quarks are a member of the fermion family. And of course, if you build up the proton with quarks, you are making a proton which must also be a member of the fermions. In fact, the definition for fermions is usually this one here. Quarks and leptons, as well as most composite particles like protons and neutrons, are fermions. So we have our third one ticked like that. So we've got three statements there. Protons are baryons, and baryons are mesons and hadrons, as we see down here. And of course, the proton is made up of three quarks. That will be a baryon, so that means that the baryon will be in fact a hadron as well. So we've got all three statements ticked, and therefore our answer to that one must be E. A proton is all three of them, 1, 2 and 3.